Hello, everyone. My name is Jongeun, and I am a PhD student at University of Minnesota. I'll talk about one of my research topics, symbolic regression. Let me explain what the symbolic regression is, and I'll take an example here, the period of pendulum. So regression is find the function that explain input and output data, and assume that we have some experiment on the period of pendulum. Like we collect, for each trial, we vary the length of the length and record the period here. And we want to find the relation between this L and T, but we don't know what is the structure of the function. For example, we don't know it is linear, exponential, logistic, or something like that. We just know maybe that function will use this kind of operators. That is all we know. In this situation, what it can do is symbolic regression. Symbolic regression only takes the input data, and also just take math operators. Then it will return some formula that explain the input and output as much as possible. So this is it. And usually to express this function, we usually use expression tree. It looks like this. So we can express this function as a tree. And this is useful when we develop some method for symbolic regression. There are several approaches here, and the most common one is genetic programming, and also there are neural net-based approaches, and third one is MINLP-based approach, mixed integer nonlinear programming, and this is related to our approach. The benefit of this approach is that within searching space, we can find the best formula. But the disadvantage of this approach is that it takes a long time because it only finds the optimal. What I've done for this topic is that first I improved the MINLP formulation so that we can solve the same problem faster than other approaches, other formulations. And the second one I developed was heuristic, MINLP-based heuristic called stretch, sequential tree construction heuristic. The idea is that we begin with a small tree and then update the tree small by small using MINLP. This approach works very well, and this approach is different from some genetic programming. That is basically, it also changed tree by each step, but that use heuristic. But we are using MINLP. That is more exact and accurate approach. So the motivation of this approach is very simple. For example, we have two formula that is very similar. Only one term is different, but it looks very similar, especially when we look at certain domain. Two function is very similar. So there's a simple form and comprehensive form. And same thing happen in real applications. For example, Kepler's third law, there's a comprehensive version here and simple version here. And only the difference is large M becomes large M plus M. So what it says is we can find the simple form first and then find the comprehensive version from the simple one. That is the main motivation of this new approach. And there's an example that we can find. This is a comprehensive form here, but the algorithm starts with a very simple form and update and update and update. And with 6 iteration, it will find the final formula, the same formula. And it only takes a few minutes, while the full MINLP takes more than 1 hour. So that is benefit and most contribution of this approach. The full document is available at the archive. So if you want to see more details, please visit the website. Thank you very much.